our session will look at forecasting. Forecasting is important in research because it helps us um, predict what may come. So we have two types of forecasting, what we call moving averages and exponential smoothing. So these are part of the types of forecasting that we have. So to forecast is simply to do what? To predict the future variables. So predicting sales, estimating the future demand, all these are called what? Forecasting. So forecasting can come in terms of what we call smoothing techniques. So when data has fluctuations, we can use what we call smoothing techniques. Okay? So it is important for us to learn about smoothing because it includes you predicting your future sales, estimating the future product, anticipating production needs. So we have what we call smoothing techniques, which is used when data has short-term fluctuations, ups and downs. Okay, so you would want to have a smooth pattern. So the types of smoothing that we're going to look at is what we call the moving average, the weighted moving average, and exponential smoothing. These are the types of um, smoothing forecasting we're going to look at. Okay, so I'll simplify my lesson by giving you something very easy to um, relate to. Then we go to this question. So smoothing is important for the reasons that we've said. What are the three reasons we talked about that are important for uh, predictions? Number one, we want to forecast sales. Number two, whatever I said was a reason. We want to predict the production needs. All those fall under the importance of smoothing. So the two types of smoothing techniques that we're going to look at for now, we're going to look at the smoothing as well as the moving averages. Smoothing as well as the moving averages. The moving averages is the easiest that we can ever learn because we are using a certain average total. So we can use a 3 moving average, can use a 5 moving average, and you calculate your mean absolute deviation. So let's look at a 3 moving average and its simple context on how it is done. So if you're given data with sales as follows, given data with sales figures as follows, for instance, you have your actual trend. For instance, you have this actual sales trend here for month one. We have 5. We have 8. We have 10. 3. We have 6. And maybe we have 4. So we want to have the moving. So we get a 3 moving average. So we get a 3 moving total. You add them in threes. So 1, 2, 3. What is our total here? What is our total? The top 3, 5 plus 10. Okay, plus 8. 15 plus 8, what do we get?
23.
23. So you put your 23, not in the same column, but in the next column. 23 here. So what is our 3 moving average? We divide the 23 by what? By 3. What do we get? 7.67, right? So we added 5 plus 10 plus 8, then the total here, divided by 3. Then we start now from 10. 10 to 3, What do we have? 10 plus 8 plus 3 is 21, right? 21 divided by 3 is 7. Then we get the total starting from 8. 8 plus 3 plus 6. What do we get? 17, right? 17 we divide by 3, we get 6.33. Then the last forecast, we start from 3. 3 plus 6 plus 4 is what? 13. 13 we divide by 3, we get what? 4.33. So we want to forecast for the next month. This can be January, February, March, April, May, June, and we want to forecast for July. So the forecast will be 4.33. That is how we do the moving averages there. Is that clear? If it was a 5 moving average, we could, because these are the two common ones. 5 moving average, so this is our forecasted trend. Forecasting. This is the actual sales, the actual trend. So can somebody guess if we're doing a 5 moving average, what will we be doing? We have 5, we have 10, we have 8, we have 3, we have 6, we have 4. 5, 8. Hmm. So I just added 2 more just to add meaning. So we're going to do the 5 moving totals. So how do we find the 5 moving totals? We get the first 5. Let's put a dash. 1, 2, 3, 4, 5. Okay. So the total here for this 5, this is 5 plus 10, 15. 15 plus 8, 23. 23 plus 3, 26. 26 plus 6, 30 what? 32. Then how do you find the 5 moving average? Which is our forecasted trend. You divide this total by the 5. So here you're going to get 6.4. Then you start counting from 10. 10 plus 8, 18. 18 plus 3 is 21. 21 plus 6 is 27. 27 plus 4 is 31. So you put your 31 here. So 31 divided by 5, what do we get? 6.2. Then you start counting from the 8 here. 8 plus 3, 11. 11 plus 6, 17. 17 plus 4, 21. 21 plus 5, 26. So put your 26 there. So 26 divided by 5, what do we get? 5.2. And lastly, that from 33 plus 6, 9. 9 plus 4, 13. 13 plus 5, 18. 18 plus 8 is 26. So 26. 26 divided by 5 is 5.2. So if you're forecasting, this is January, February, March, April, May, June, July, August, and then to forecast for September. So this is how we do the forecasting. Are we together? Any questions so far? Please ask. Is it complicated? We're getting lost because I need to look at the other technique. So you understanding this will help me understand the other technique and explain this properly. Any questions? Anyone behind? Anyone behind? Are we together? So that is how we do the moving averages. So we can now calculate the mean absolute deviations for that one. But before we look at the mean absolute deviation, we can look at the exam question now. This one is coming, like it or not, so you need to understand it from the basics so that you're able to apply what you need. Okay, so when we're dealing with uh, forecasting, which is exponential smoothing, we're predicting using a formula that will be given. So exponential smoothing is under time series because it uses past um, observations to predict the future. It assigns weights, either increasing or decreasing data to predict your um, future trend. So we're going to use a formula that I need you to memorize. Okay, so exponential smoothing, it assigns weights in the order values, meaning the recent observations will be more influential. So this is called exponential because the weights assigned to the data point will decrease exponentially. So the purpose of this is that it is used to predict future sales. It is used to smooth out random variations and make what short-term forecasts. So it is important for sales forecasting, inventory demand, banking, and financial predictions. This is what is mainly used in those categories. So the formula that we use in exponential smoothing is given as follows. So we have basic formula that we use, which is to predict the future sale. F plus T is the forecast for the next period. We have AT times alpha. Our actual value is AT on the current period plus 1 minus alpha and the forecast for the current period. So our A should be between 0 and 1. Okay, so these values you have, AT is the real data that we have, FT is a predicted value. Then the alpha ranges between 0 and 1. It determines how much weight is given to the most recent observation. So if you are close to 1, it means the focus reacts quickly to the changes. It is less smoothing. If we are close to 0, it reacts slowly. Okay, so you can be given our alpha depending on what you have. So, for instance, if you're given our actual forecast for the week to be maybe 110, using this formula, our forecast, our actual trend is 110, our forecast is 90, and our alpha is 0.3. So here we say the formula is ft plus 1. So alpha times the actual, so 0.3 times 110 plus the remainder. 1 minus this is 0.7, so 0.7 times 90. So we get what? 96. So this is how we calculate our formula here. So the forecast for the next period is 96 units, is slightly higher because the demand exceeds 110. So this is how the forecast is done. All right. So we are going to now look at this question with the information that we've learned so far.
Just a minute.
Mm.
How did you get the 0.7
From the 0.3, like
or
P
from
and Q.
100?
Yes.
Okay.
How did we get the 0.7 from there? 100, because the formula that we're using is as follows. We calculate our alpha, or the forecast set for the next period, as alpha 81 minus that. Okay, so we talked about what alpha is. The closer you have to that, the more. So we're given data here to forecast for this period using that formula. So the data that we've been given here is as follows. So we are given week 9 up to 13. The actual data is what? 110,000. So if you're given our alpha, how do we calculate the forecast for this period? Who remembers the formula? The formula is what? The formula is what? So to fill in those particular, we're given the initial formula. So we're doing alpha 81 minus alpha. So how do we get this 85 here? Okay. So I want us to utilize the concepts that we've learned so far without complicating this. So as an analyst, you've been asked to consider the following constants: 0.1, 0.2, 0.3. You want to compare the accuracy of the smoothing constants for a 10-week period. So we're given that the actual demand is 85, 100, 110, 90, 105, and 95. So we want to calculate the missing areas here. Okay, so we need to fill up row 10. So what was our formula for calculations?
It's
Uh-huh.
F1 is equals to alpha
Uh-huh.
A T minus 1 plus,
This one. Uh-huh.
in brackets,
Mm-hmm.
1 minus alpha, close
Mm-hmm.
bracket, FT minus 1.
FT minus 1. Okay, so how do we forecast for week 10, therefore? So what is our alpha for week 10? 0.1 for this column. So we want to see what answer we're going to have there. So we're going to put what? 0.1 as our alpha there. Uh-huh. Then the actual trend, what is our actual forecast for that period?
90.
The actual forecast is what?
90.
So we want to look at
Oh,
the forecast for the following year. So we're using the data here. Okay. T plus 1 means the next year. So what are we using? 110, right?
yes.
Mm-hmm. Plus what? 0 point what? 0.9. Where's the 0.9 coming from?
It's 1 minus alpha.
The 2 must add up to what? 100. Okay. Then ft minus 1. What is our forecast for here? 85. Okay. The forecast here. Okay. 85. ft minus 1 to the previous year. So 85, this is 85 there. So when you compute that, you're going to find your missing value in there. So the missing value in there will be what? 87.5. 87.5. So you do the same for the others. So what it means that ft minus 1 means the forecast for the previous. So these are forecasts here. So if you're dealing with this year, the ft minus 1 means last year. Ft plus 1 means